let's talk about mixtures. All right, mixtures. William, I appreciate that, but I would really appreciate if you'd be a little more attuned to that and actually stay focused, okay? All right. All right. Now, in earlier science classes, you learned about two classifications of mixtures. And one of those classifications was called heterogeneous, and one was called homogeneous.
Oh, I remember this. It's the same and it's like heterogeneous.
Well, you know what? You know what? Listen. Now, yes, in your earlier science classes, you would have been told, or could have been told, that you could actually see the different kinds of particles. Okay? In chemistry, it's not that simple. No. There are heterogeneous mixtures where you cannot see or feel. You cannot use a microscope to tell the difference. Okay? You got two major classifications, heterogeneous and homogeneous, okay? The only true homogeneous mixture solution. Okay? Well, while that's a good illustration, okay, it's much, much too big. Okay, the particles are way too big, really, to talk about what we're talking about now.
They said homogeneous is Kool-Aid.
Okay, homogeneous would actually be a good example of a homogeneous solution because it does look the same and it actually is a solution. All right? So solutions are mixed particles.
Oh, are you waiting for us to finish it?
I'm waiting for you to write it down. Mixed of particles
you cannot see.
That are a nanometer in diameter or smaller. Okay. All right, now let's talk about how small a nanometer is. Let you write that down. Okay, how small is it? All right. How big is a meter? Quiet.
It's like the size of my mold.
No, a meter. A meter.
Like a meter stick?
Like a meter stick. How long is a meter stick?
A meter.
Like 3,600.
Aren't you clever?
Okay. All right. You see how high this desk is right here I'm pointing at?
Yes.
That's less than a meter. It's a little bit higher than that from the floor to be a meter. Okay. If you were to take a meter stick and cut it into 1,000 pieces, equal length, okay, slice it across the sideways. If I'm standing it up like that, slice it across sideways in 1,000 pieces, you'd have millimeter-sized pieces. Okay? Now, how big is that? So there's a ruler, and here are centimeters, and these little tiny markings right there, millimeters. All right, listen carefully. Imagine we could take one of those tiny little sections right there. So we chopped up our meter stick into 1,000 pieces. We get pieces that thin.
You
Suppose we chop those up into 1,000 pieces. Okay? Chop up, that's like, no, yeah, you're right. We couldn't make it that small, could we? All right? But suppose we could, just imagine we could make it that small. Okay? Then take one of those tiny little slivers and chop that into 1,000 pieces. Now you got a nanometer.
It's very small.
Okay? Well, we would think of it as nothing, but it is a pretty major something for chemists. Okay? All right. So the particles in a solution, the solvent particles, we don't often think about them as particles. We're talking about molecules here. The solvent molecules and the solute molecules, or ions, whatever they are. Okay? If they're mixed such that those solute and solvent particles are a nanometer or smaller, that's a solution.
Would something be really, 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 really tiny?
Mm-hmm.
Still be a solid?
Well, would it be a salt? You said a what?
A solid.
A solid?
Yeah.
Yeah. You could have it that small, but when we mix a solution, what we often think of in the chemistry lab is you've taken the individual particles and broke them apart, separated them all out, and mixed them into water. Okay, and then the particles are all that small, so you don't really have a solid, but you could have solids that are that small. Okay? All right. And so, for a chemist, a true homogeneous mixture is a solution. So when you were taught about homogeneous mixtures in physical science, you were not asked to use your imagination much. They gave you examples that you could kind of see. All right? But now you're going to have to use your imagination to imagine something that small in order to grasp the concept of what a solution is, and therefore what a homogeneous mixture is. Okay? Now, there are lots of examples of solutions. There are solutions that are made of gases. So gas solvents dissolved in gas solutes dissolved in gas solvents. Okay? You're breathing that right now. An example is air, where the major component in air is nitrogen.
That gas dissolved in gas?
Mm-hmm. And there are a number of gases dissolved in that nitrogen. About 70% of what's in the air is nitrogen. About 20% is oxygen. Yes. There are components in the air that are water vapor, carbon dioxide, and all of those are gases dissolved in a gas. Okay? Although you could think of water vapor, since our temperature in here is less than 100 degrees, ladies and gentlemen, if you're talking amongst yourselves, you're not paying attention to this. You do not get to make up any points on this next test. We're past that point today.
I'm sure it is.
We don't?
No,
Why? One more test left in his
Why?
because I don't have time to grade makeups.
Yeah.
Okay? So you really, really need to pay attention. Okay? So we could consider water vapor dissolved in the air, in nitrogen, as an example of a liquid dissolved in a gas. A liquid solute and a gas solvent. Okay? If we consider water dissolved in the air. Okay? There are solids that are dissolved in the air. There are particles that are small enough to be a nanometer in diameter that are floating around the air right now. Okay? That would also make a solution where you have a solid dissolved in a gas. Okay? That happens when you have, sometimes that happens when you burn something, if the particles are small enough. Most of the time, if you can see the smoke, the particles are not small enough.
Same thing as gas, a liquid.
A liquid dissolved in a gas is water. Water vapor dissolved in that. Are you looking on the list in the handout?
Yes, sir.
Say what?
12.
What page are you on?
Oh, I'm talking about the practice test.
Oh, the practice test. Well, yeah, these are examples of that, but there's also examples of these, I think, in the unit handout. Well, I don't see it right quickly, but I thought they were in there. Okay.
So, it can be reversed, liquid and gas, liquid.
Sure. Okay. What would be an example of a gas dissolved in a liquid?
Yeah,
Yeah, if you make a soft drink, it has carbon dioxide dissolved in water, doesn't it?
So, put CO2.
Well, carbonated water, such as the water that's in soft drinks. Okay. What would be a good example of a liquid dissolved in a liquid?
Ice.
Ice is a solid. Hmm? Well, seawater is mostly solids dissolved in a liquid.
Oh, when you put like, I don't know, like you put like a chaser, like liquor,
Okay.
and you taste it.
Alcoholic beverages. Alcoholic beverages are examples of a liquid dissolved in a liquid. But for that matter, so is isopropyl alcohol, where water is dissolved in alcohol. There are some alcoholic so-called beverages where the amount of alcohol is much greater than the amount of water. In that case, the alcohol is the solvent and water is the solute. Yes?
This guy never filed his test.
What now?
This guy never filed his test. I guess it's been on my desk.
Oh, well.
What do we do with it?
Hand it to me, I guess.
Just looking through it.
No, it's like, I mean, I just noticed.
Is it for I
No, I don't think so.
Okay.
You never seen it like that.
All right. So an example of a gas dissolved in a solid. Okay. Well, let's do it. First of all, let's do a solid dissolved in a liquid. Liquid dissolved in a liquid is alcohol.
So gas to a liquid is carbonated water.
Yeah. All right. Then you could do a gas dissolved in a solid.
And what is this?
What would be an example of a gas dissolved in a solid?
gas to a solid would be
I don't know what that would be.
No clue.
Do we eat it?
I wish nothing but
Jello.
Is it Jello?
Let's see.
Jello.
I'm trying to think if Jello would be exact. No, I don't think you can really. I don't know if you can call.
Mayonnaise.
Mayonnaise. That song is
Is it mayonnaise?
I don't. Mayonnaise is a colloid. It's a different thing.
Ew. How do you do that?
like with eggs.
Yeah. You might have one.
That's what you're supposed to use.
What did you do? You looking it up?
I thought this was in the unit handout. I was trying to see.
Oh yeah, we made mayonnaise. It was nasty.
Yeah, like,
It's like Jello. Maybe it's like sour
Sour.
mustard and like who mayonnaise you made? Your brother.
What?
Real good.
There's
Right.
not a liquid that's dissolved in gas.
What? I'll make your own mayonnaise.
I can make my own.
Make my own mayonnaise?
I always say my name.
What are you talking about?
Girls always get my name. I'm like, really close.
Well, I thought I had a whole list in here. Okay. Okay. All right. I'm looking at everybody. All right. Huh? I'm looking at the room. I'm not looking at one person and stopping there. I'm looking around the room. Yeah, I looked at you. I scanned. I said everybody. All right. I'll think of a gas and a solid in just a minute. Okay, we'll come back to that one. We had gas in a liquid, solids in a liquid. Solids in a liquid. I hadn't done that one yet. That would be like what? Sugar, salt.
What?
Yeah, sugar, water,
Yes, solid is sugar. We can't see it.
Okay, so your Kool-Aid example was a good example of a solid dissolved in a liquid.
Put a little teeny particles of solid.
You could do iced tea, Mr.
Iced tea.
With ice in it, yeah. Like that.
Well, ice is not dissolved because the ice particles would have to be smaller than a nanometer.
I would say, yeah, iced tea, but tea.
What? I didn't understand what you said.
What about smooth?
No, rain is not dissolved.
What about smooth? What would a smoothie be?
That's a coarse mixture. Okay. All right, let's see. How about something in a solid and a solid?
Solid and solid.
Solid and a solid.
I don't know.
Yes. What would be a good example of a solid dissolved in a
We
solid?
don't know.
Hold on,
A salad. Dry ice.
That's not dissolved.
Right.
Those particles are not smaller than a nanometer.
Right.
Like when you put stuff like spices and stuff like that together.
Soup.
No, solid.
Steam.
Liquid.
Steam is a gas.
I get a book. What about a ham?
Steel.
Pop-tart.
Steel? Oh, okay.
Titanium.
What about pepper food?
Because you gotta melt stuff.
Quiet.
A grilled cheese.
Pork chop.
Quiet.
It's not normal.
Guys, you really you should look. If you can't talk one at a time, then you should be raising your hand. If I have to say raise your hand for everything, we can do that. Otherwise, grow up a little bit, okay? Really? Yes. Yes. Okay. All right. So solids and steel will be a good example. Steel is carbon dissolved in iron. Steel is carbon dissolved in iron, and there are lots of different kinds of steel. If you dissolve carbon and chromium in iron, you get stainless steel. Okay? If you dissolve tungsten and carbon in iron, you get a very hard type of steel. Yes?
What is steel wool made of?
Mostly iron. There's actually very little carbon in steel wool.
You know what I'm talking about? Like
Yeah. I know. I've got bunches of it back there.
I mean, the Brillo pad. That's
Yes.
the same thing?
Yeah. A Brillo pad is just steel wool with soap caked on the outside. Okay? All right, let's see. A solid. How about a liquid dissolved in a solid? Ice is not dissolved.
Well, it's not. Ice cream dissolved.
However,
Ice cream.
Coffee.
Ice cream.
a liquid dissolved in a solid. How about
Ice cream.
a popsicle would be a good example.
I said ice cream.
Okay?
All popsicles.
Yellow and yogurt.
How do you spell sickle?
Sickle.
C-Y-C-L-E? Okay. All right, listen. an ice cream is actually more of a colloid, but there are some solids dissolved in solids in ice cream. Yes.
Ice cream cake.
Did you
I love that.
No.
Ice cream and cake.
We aren't that far along yet.
We're in colloids.
We are not in thermochemistry though. Yes. Yes. All right.
Oh my god.
Okay, how about now we're back to gases dissolved in solids.
How could a gas dissolve in solid?
What?
Why couldn't it be Jello? You said it.
What is Jello?
Jello is not a true solid.
Is that a colloid?
Well, it's a semi-solid. It's not really a solid. Yes. No, smoke. If you can see it, the particles are too big to be dissolved. Smoke is more of a suspension. So smooth. Okay. Sure.
Thank you.
Sure. All right. Gas is dissolved in solids.
That's what pops in my head.
I'm real mad about this ad.
There are some methane. Methane is dissolved in coal. There are methane gases dissolved in coal.
What do we use coal for besides Christmas?
I don't think anybody gets coal for presents for Christmas anymore.
You
But
think coal is something you cook on
Did
the
you?
grill, Mrs. Taylor? You usually cook on the grill, right?
well, that's charcoal. It's a different thing.
What's the
Yeah.
difference?
Charcoal is not made in the ground.
Oh. It's in my stocking. What's the
All right.
Gave me a rotten one, that's what-
So if you have methane as a gas and coal that comes out of the ground, we use it for making most of the power in the United States.
That's why I be on trains.
Yeah. See it on trains all the time. Huh? Eventually, it's a finite resource. Okay, there's only so much coal on the ground. And then after we've used it all up, we don't have any more. Hmm? Well, hopefully we're going to find some other sources of energy.
Like what?
But we don't seem to be getting there very fast, do we?
And which one you use for gas and solid?
I used the example of methane dissolved in coal.
I feel sick. Oh, what's the word?
methane and coal?
All right, let's see. Did I do a liquid dissolved in a solid? Oh yeah, I did a popsicle. Okay, that's good. All right. So listen. Solutions can only be separated. The solute can only be separated from the solvent in a solution using some chemical process.
Wait, go back, Mr. Taylor. Where you got the paper?
The parts of a solution, that is to say the solute and solvent, can only be separated using some chemical process. Look, maybe it's time for me to say no one talks unless you want to stay after school.
No, don't say that.
Well, then you better start being more mature. Okay? So solutions can only be separated using some chemical process. Some of those chemical processes include distillation.
Did you ever enter the gas dissolved in solid?
Yes. Yes. What is a liquid dissolved in a solid? Popsicle. No. Yeah, that's be right.
You
What?
think of one yet? Gas is solid?
Methane and coal.
Methane and coal.
All right. Distillation is an example. Crystallization. Anybody know what distillation is?
Yeah, it's like straight or not like
You had a solid or a
Finish
liquid
water
or
it's distilled.
filter.
Okay.
They got you.
It's not filtering. All right, listen carefully. I'm going to give you an example or a definition or an explanation of what distillation is. Distillation is how you separate usually two liquids, but you can actually use it for other properties too, but typically it's used for two liquids, and you boil it, and then you collect the gas, the vapor, and if you're careful with the process and careful with the temperatures, then the vapor can be condensed and will be higher in concentration of the liquid that has the lowest boiling temperature. Okay? Distillation is where you boil two liquids that are dissolved together. You collect the vapor, and if you're careful about the temperature and other conditions, if you're careful about the temperature in particular, then the condensed vapor will have a higher concentration of the liquid with the lower boiling temperature. You'll have a higher concentration. The stuff you've condensed will have a higher concentration of the liquid with a lower boiling temperature. Yes. Quiet, please.
I was giving her advice, Mr. Taylor.
Yes, well, your advice needs to wait till later so that people who are asking questions about chemistry can be heard.
Oh, no. I was telling her to put her hand up before she got in trouble because I saw you looking at her. I was trying to be a good Samaritan.
Well, I appreciate you being a good Samaritan, but try to do it in a whisper, okay? Yeah, good example of a whisper. Thank you. The condensed vapor will have a higher concentration of the liquid that has the lower boiling temperature. And we often talk about distilling water, but really with water we're actually settling out solids and not so much separating one liquid from another. And that's okay. I mean, we call it distillation, that's perfectly okay. All right? So sometimes you can also separate out the solids. Okay? All right. Crystallization. You remember our example of a supersaturated solution? Where we actually cause crystals of sodium acetate to grow?
You caused it.
Yeah.
We did it.
Well, that's kind of like crystallization, where we could take then the solids out. Okay? Mm-hmm. All right. Does that make sense?
Yeah. That's supersaturated.
Well, with crystallization, eventually you get supersaturation. That's true. Okay. All right. Evaporation.
Evaporation just goes away. Like
Yeah, and usually crystallization and evaporation kind of go together. When you first crystallize it, and then you evaporate all the liquid off of it, or boil all the liquid off of it. Okay. So if you're boiling it, it's straight crystallization. But if you're just waiting for it to evaporate, that's still you're just putting two processes, crystallization and evaporation, together. Okay. All right, so those are ways of separating chemical solutions. Okay, now, heterogeneous then mixtures. There are two kinds of heterogeneous mixtures, actually three. You have colloids.
Oh, 2 or 3.
What?
You wanted to know that it's 2 or 3. You might have it on the test.
Colloids, suspensions, and coarse mixtures. Okay, colloid, suspension, and coarse mixtures. All right, colloids, particles are between 1 nanometer and 1,000 nanometers. So the particles in a colloid are between 1 nanometer and 1,000 nanometers. So remember, in solutions, they're smaller than a nanometer. In colloids, they're greater than a nanometer and less than 1,000 nanometers.
Mr. Taylor,
Mm-hmm.
is coarse mixture solutions?
No.
Oh,
The only solution are these over here.
that's solution. Okay.
Mm-hmm. All right. So some examples of colloids.
That's the SN14 type.
Fog,
It's fog for colloid. Colloid is mayonnaise too. It's what?
plain milk. Yes, mayonnaise.
Tomato.
What's this? Oh, yeah, got to it.
How does fog? Plain milk.
The particles in fog, typically, are between a nanometer and 1,000 nanometers.
It's got a light.
They scatter light. Okay, so one way to test if you have the right kind of colloid, not every colloid can be tested this way, but colloids that appear, if they appear transparent, colloids will glow. If a narrow beam of light is shined through. And that's called the Tyndall Effect. Okay? So they might appear to be transparent, but if you shine a narrow beam of light through it and it kind of glows, that's called the Tyndall Effect, and that's what happens with colloids that otherwise appear to be transparent.
So you're saying that if you get mayonnaise and get
Well,
And what I said was not every colloid can be tested this way.
oh, okay.
Mayonnaise can.
Mayonnaise cannot.
Yes, it can. No, it
Fog can.
Mayonnaise can.
What happens when you shine your headlights through the fog?
Does it do
It
it?
goes
It's
through
dim.
somehow.
Isn't it good?
Yes, it does.
you can see through it.
Makes it worse.
Can't
That's
see
about
through
when
it.
you
It
drive.
scatters light.
It does. It makes it worse. Everything glows out in front of you.
I know, but you still can go through. Like,
What's a fog like?
Okay, I want you to think about it a minute, Amber. I want Amber, Todd, Amber, be quiet and listen.
what do you mean? Like I was the only one listening.
I called Amber's name about 4 times before I called yours.
I was listening to you.
You're not happy.
If I can't control you through a discussion like this, then we can do worksheets. Would you rather do worksheets?
Can we work together?
Yeah, she was snoring like Robbie.
Quiet, please. Quiet, please. Pay attention, please. Obviously, you can't shine a light through mayonnaise. But if you shine a light like the headlights of your car through the fog, I want you to think about the difference between what that looks like and the headlights shining just in the dark when there is no fog.
You can see.
Okay.
What happens with the fog, it glows in front of you, making it harder to see further down the road.
Okay, I got it.
Okay? That's an example of the Tyndall Effect. Okay?
So you can just see up close, but trying to get down, but you can't really see because it's up in your face.
Okay? And so if you're walking down the street at night in the fog when there isn't any light, it might appear to be pretty transparent. It's only when there's light that it starts to glow. Okay? And there are lots of colloids. Shane, there are lots of colloids that appear completely transparent until you shine a light through it. Okay? Yes.
What is the word after narrow? Because I can't see
After what?
it. Narrow.
Beam.
A narrow beam of light.
So mist is a colloid, right?
I would actually consider mist to be a suspension. Fog, I would consider to be a colloid.
Dew. Is dew a suspicion?
Yes.
Yeah, dew is. Dew is a
Bailey, I'm answering trying to answer your question.
Oh, that's interesting.
Yes.
Is dew a suspicion?
What?
Dew.
Dew's not a suspension once it's on the ground. It's not anything.
So it's just
What's a solid solution, Mr. Taylor?
Steel.
Okay. Liquid solution?
All right, look, I've already gone through these, really.
Oh, that's a different question, but it's like, I think it's basically the same thing.
Yeah, but
Okay, I've already gone through all these. Okay, let's move on.
wait. So gases
Yeah.
would be methane and coal?
No, I'm talking about, it says, on here it says 13, give examples of solid, liquid.
I'm not talking about the practice test right now.
It's the same thing, isn't it?
I'm not talking about the practice test right
I
now.
won't be talking about it no more.
Well, how are we going to get to that?
Don't worry about it, don't talk about it. You want to talk about it, we'll talk about it.
I want to stay on one thing at the moment, and then I can come.
Just be quiet, everybody.
All right, let's talk about suspensions now. Suspensions are mixtures that will stay in this mixed state for a short period of time. Suspensions are mixtures that will stay in that mixed state for a short period of time, but will settle out on their own if left undisturbed. Shane.
Yes, sir. I'm trying to stay on my subject.
Suspensions are mixtures that will stay in this mixed state for a short period of time.
Can I give an example?
Not yet.
Oh, you can stay on the subject.
That's what I'm saying. No.
But will settle out on their own if left undisturbed. Okay, think about muddy water. Okay? Yes, well, we're not talking about the artist. We're talking about real muddy water. Okay?
What about this is
Can we stay on this subject for just a minute? Hold on. Hold on. quiet. If you have small particles,
I can't concentrate either. It's all ADD.
It's a snow globe.
it's not a snow globe. You have small particles that, like in a pond, okay, like muddy water, okay, so that it appears to be stirred up for a period of time. But if you were to take a jar of this stuff and put it on the counter and leave it alone and come back the next day, most of those solids are on the bottom. That would be a
So
suspension.
that's not a snow globe? Like you shake the snow globe?
No, snow globe kind of looks like it, but a snow globe is not a suspension because it doesn't stay suspended for any period of time. A lava lamp is a different thing.
That is?
Yes.
In the suspension?
But still, if you turn the lava lamp off, it goes green.
And we gotta stay on subject.
It's a different thing.
We're talking about suspension. How's it not on
Okay.
subject?
Chocolate milk. The cocoa in chocolate milk is a suspension.
Coffee.
If you take, not coffee, if you take chocolate milk that you make, you know, the syrup you buy in the grocery store, and stir it up in the milk and leave it in the refrigerator, in a few hours all that cocoa is going to be on the bottom.
Yes.
Tea will do that too. If you look at the bottom of your tea, it'd be like little teapot.
Okay, maybe so,
Hot chocolate.
in which case I suppose that's a suspension, but no tea I've ever made does that. Yeah.
Like Mr. Teddy.
Yeah.
Like when you make hot cocoa in the cup, it's like feel like no matter how much it's stored, it's still like clumps of
Yeah, that's kind of a different thing. Yeah. Okay. Now, so an example of a suspension then is muddy water. Not muddy waters, the musician. Okay. Or chocolate milk. We talked about it a whole bunch over here. Okay, now coarse mixtures are like salads. Okay? They won't even stay suspended. Okay? They won't stay mixed up even for a short period of time. Okay? Alright. Now, suspensions have particles that are greater than 1,000 nanometers. Particles are greater than 1,000 nanometers. Okay? So you've got solutions with particles less than a nanometer, colloids with particles between a nanometer and 1,000 nanometers, and suspensions with particles that are greater than a nanometer. But it's not true, even with a particle that's greater than a nanometer, if they don't stay mixed for a short time, and they settle out, if left undisturbed, if they don't meet these conditions, then they're not really a suspension, they're a coarse mixture.
You